Hello everyone, and on this video we will be figuring out how to simplify radical expressions. Okay, now these steps that you see here, they're just guidelines. Okay, there are plenty of other methods to solve. This is just these steps that I would recommend following until you get really comfortable doing it, and then you can do whatever process comes naturally to you. Okay, so your first step would be to change the radical expression to an exponential. Okay? So that's only if it's necessary. A lot of times it won't be necessary depending on how the problem is presented to you. So for example, the cube root of 5, you would change that to 5 to the 1/3 power. So you have an exponential expression instead of a radical one. Okay, now your second step will be to simplify the radical expression, which means you're going to distribute, combine terms using the rules for exponents, etc. Okay, now your third step would be to change the exponential expression back to a radical, but that's only if you changed it in the first place. So if you didn't do step 1, you don't have to worry about step 3. Okay, so you only have to do step 3 if you had to do step 1 at the very beginning. Alright, so if you're still writing, feel free to press pause. But right now we're going to start on some examples. Alright, so let's say, for example, if you wanted to simplify say 5 and to the 2/7 power times 5 to the 3/7 power. Okay. Now the thing about this one is that it's already written as exponential terms or factors. So you don't have to convert it from a radical to an exponential. It's already an exponential. Okay, so we can go ahead and just do step 2, which is really simplifying the radical expression by combining those two terms. Now, if you remember, I'll put this in little brackets here. You have x to the power of m times x to the power of n. That equals x to the m plus n. Okay, remember your product rule for exponents? That's how it would apply. As long as your bases are the same, you can just add your exponents. So since both have a base of 5, that really just becomes 5 to the 2/7 power times 5 to the 3/7 power is equal to 5 to the 2/7 plus 3/7 power, which would give you 5 to the, remember when your denominators are the same, you just add your numerators, so 5 to the 5/7 power. Okay, so that would be your simplified answer. Now, if the homework called for you to convert that to a radical, then that would become, remember, your denominator becomes your index. You have your whole number, and then you have your numerator will be on the outside. So that's only if they wanted you to put it as a radical number or radical expression. Okay, so either one of these would be your correct answer. But in most cases, since you started off with exponential expressions, your answer will be in an exponential expression form. This is just a just-in-case kind of thing. Okay, so let's say, for example, we wanted to simplify 11 to the 2/7 power, and that whole thing raised to the 3rd power. Alright, Alright, so just like before, we're going to look at our rules for exponents and see which one applies here. Now, if you remember, you have x to the power of m, and that whole thing is raised to the power of n, then that's just x to the m times n. Okay, so the same thing applies here. You have 11 to the 2/7 power, and that whole thing is raised to the 3rd power, then that just becomes 11 to the 2/7 times 3 power. Okay. And remember, 3 is just the same as saying 3/1. So that's 11 to the 2/7 times 3/1 power. And remember, when you're multiplying fractions, you just multiply your numerators and your denominators. So that will equal 11. 2 times 3 is 6. 7 times 1 is 7. So 11 to the 6/7 power. Okay, so all those little exponent rules from the last video are kind of coming back. Okay, that's why I wanted to make sure we went over those first. Okay, so let's say for this example, we want to simplify. Let's say a, let me clean up that a little bit, to the 4/5 power times a to the 1/5 power plus a to the 3/5 power. Okay. Now the one thing you might want to start and go, okay, well, this is 1 to the 5th, this is 3 to the 5th, I'm just going to combine those two. You can't do that, and here's the reason why. These are completely different. That's like trying to combine x squared plus x to the 3rd. If they're not exactly the same, you can't combine them. Okay, so just remember, you can't combine them unless they're exactly the same as far as plus and minus goes. With multiplication and division, it doesn't matter. But with adding and subtracting, you can't combine those unless they're both exactly the same, variables and all. Okay, now the first thing we're going to do here is we're just going to go ahead and distribute, because we want to get rid of those parentheses. So you have a to the 4/5 power times a to the 1/5 power plus a to the 3/5 power. We're going to go ahead and distribute that a to the 4/5. Okay, so that's going to equal a to the 4/5 power times a to the 1/5 power plus a to the 4/5 times a to the 3/5 power. Okay, so same distributive property as always. Okay, so if you go back up to our first example, where if you multiply two factors with the same base, you just add the exponents. So same thing is up here. So if you have the same base with both a, you just add your exponents. So you have a to the 4/5 plus 1/5 plus, same base here, a to the 4/5 plus 3/5 power. Okay, so now we go ahead and we just add our fractions here. So you have a to the 4 plus 1 is 5, sorry about that. And since the denominator matches at both 5, our answer is going to be over 5. Plus a to the 4/5 plus 3/5, so that's a to the 4 plus 3 is 7, so that's 7 over 5. And 5 divided by 5 is just 1, so a to the first power is just a. That's going to equal a plus a to the 7/5 power. Now remember, you can't combine terms unless they're exactly the same. So this would actually be your final answer here. Okay, so now let's go to another example. Okay, so let's say if we wanted to simplify, say a to the 8/3 power times a to the 1/3 power divided by a squared. Okay. Now, since this is multiplied, you go ahead and use our product rule for exponents. So if we have a to the 8/3 power times a to the 1/3 power over a squared, that's just going to equal a to the 8/3 plus 1/3 over a squared. Okay, so we go ahead and add our numerator here. That's a to the 8 plus 1 is 9. 9/3 power all over a squared. 9 divided by 3 is 3, so that gives us a to the 3rd power over a squared. Okay, so if you remember, a to the m over a to the n equals a to the m minus n power. So that means this would just become a to the 3 minus 2 power, which is just a to the 1st power, or just a. Okay, so the type of problems you'll see can vary. Okay, so it all depends on how well you understand your rules of exponents. Okay, if you know how to apply those very well, you can kind of zoom through these with not a lot of difficulty after a little bit of practice. All right, so let's say for our next example, what if we wanted to simplify say 2x to the 1/5 power and that entire thing raised to the 4th power all over x to the 3/10 power, or the 3/10 power. Okay, so the first thing we're going to do is with this one is we're going to break down each step and what rule we use to break it down. All right, and remember, there are multiple ways you can solve this one. This just happens to be the way I solve it. Okay. So first, I'm just going to rewrite where we're starting. So you have 2 times x to the 1/5 power raised to the 4th power all over x to the 3/10 power. Okay, now the first step I'm going to use here, remember if you have a times b to the nth power, that equals a to the nth power times b to the nth power. Okay, so basically we're just distributing that exponent. Remember, that's the power of a product rule. So all we're going to do up here is distribute that exponent. Okay, so that's going to equal, we go right up to there, 2 to the 4th power times x to the 1/5 power. Remember, that's going to be to the 4th power all over x to the 3/10 power. Okay, so all we did was just get rid of those parentheses by applying that one rule here. Okay, so now just on this portion of it, x to the 1/5 power to the 4th power, we're going to apply, let me kind of separate this a little bit. Remember, a to the power of m, and that raised to the power of n, is going to equal a to the m times n. Okay, so that means this is going to be 2 to the 4th power. Remember, 2 times 2 times 2 times 2. Let me kind of bring that up here. 2 times 2 times 2 times 2 equals 16. So we're just going to make that 16. So you have 16, and you have x to the 1/5 times 4 is 4/5. You have x to the 4/5 power over x to the 3/10 power. Okay, now probably the easiest way to simplify this is to separate it based on whether it's a number, variable, whatever the case may be. Okay, so we're going to go ahead and separate this again, because right here, let me separate that. We have x to the m over x to the n equals x to the m minus n. Okay, so these are all the rules that we've used so far just in this one problem. Okay, so if we separate this, remember 16, that can just be 16 over 1. Or you can just pull it out to the front. So you can have it 16 times x to the 4/5 over x to the 3/10. All right, so I'm going to move this up a little bit, and I'm going to go ahead and just simplify this down here on the corner. Okay, so x to the 4/5 power over x to the 3/10 power is equal to x to the 4/5 minus 3/10. Okay, now remember, you can't add or subtract fractions until your denominators match. Okay, now once your denominators match, you can go ahead and add and subtract. So what we're going to do is we're going to make that x to the, and instead of 4/5, we're going to multiply this by 2 over 2 minus 3/10. Okay, by multiplying that 5 times 2, we get the same denominator of 10. Okay, so that's going to equal x to the 2 times 4, which is 8, over 2 times 5, which is 10, minus 3 over 10. Okay, so 8 minus 3 is 5, so that gives us x to the 5/10 power. And 5 divided by 10 is actually 1/2. So we have that x to the 1/2 power. Okay, so that means this, we're just going to bring that right down here. So x to the 4/5 divided by x to the 3/10 is x to the 1/2. So that's 16x to the 1/2 power. Okay, and that's your answer for that. Okay, so now we're going to look at combining radical expressions. All right, so to combine radical expressions, okay, we just have to kind of go back and look at some rules a little bit. Okay, so remember, let's say if you have two factors, let's say 28 equals 4 times 7. Or let's say 54 is equal to 27 times 2. Okay, we can actually convert square root of 28 is equal to square root of 4 times 7. Or we can make the cube root of 54 equal the cube root of 27 times 2. And both of these can be separated. So we can make that the cube root of 4 times the cube root of 7. Let me clean that up a little bit. Or we can make this one the cube root of 27 times the cube root of 2. Okay, which brings us to our general idea. So in general, the nth root of a product, I'll clean that up some, of two numbers is equal to the product of their nth root. Okay. Now I know that may sound a little confusing, but this is really all it means. The nth root of a product of two numbers, let's say we call that A and B. So we have the nth root of a product of two numbers. That's equal to the product of their nth root, which means you have the nth root of A times the nth root of B. Okay, so all of this up here basically just means this statement here. That if you have the nth root, you can just separate the two. All right, so let's go ahead to our previous examples here and finish those off. Let's say we have our square root of 28. Let's say that's question A. Now let's say for question B, we want to simplify square root of 54. Okay, so if we go ahead and solve this one, we know that square root of 28, we know that's 4 times 7. That's square root of 4 times 7. So remember, since we're multiplying, we can separate them. So that's square root of 4 times square root of 7. Square root of 4, remember, we're not doing, we know it's positive or negative 2, but when simplifying, we're just going to go with the positive value. So square root of 4 is equal to 2. And square root of 7, that 7 is not a perfect square. So we're just going to leave that as square root of 7. Okay, so square root of 28 simplifies to 2 square root of 7. Okay, let's do the same thing with square root of 54, step by step. Remember, 54 is 27 times 2 cube root. Sorry about that. Kind of forgot that exponent there. So we have the cube root of 54. Remember, that can just be the cube root. 54 is 27 times 2. And remember, you could have picked a different set of factors for 54. But what we wanted to do is we wanted to find a product, or better yet, a factor that was a perfect cube root. That's why we picked 27. The same thing here. We wanted to find a product with a perfect square. We could have picked 14 times 2, but we didn't because 4 is a perfect square. Same thing here. We wanted to pick a perfect cube. Okay, so if we go ahead and separate these two, we have the cube root of 27 times the cube root of 2. Okay, now the cube root of 27, what we're going to do is right here at the bottom, I'm just going to kind of solve this one separately. And this is where the steps from the beginning come in. If you wanted to convert it, but you don't have to. Cube root of 27, remember that's just any value that you can multiply to itself 3 times to give you 27. Okay, so if you remember, 3 times 3 times 3 equals 27. So that means cube root of 27 equals 3. Okay, so this cube root of 27 becomes 3. And the cube root of 2, excuse me, can't really simplify that anymore. So that's 3 times the cube root of 2. All right, so let's go do a few more examples. Okay, so let's say, for example, we want to simplify. Let's say for problem A, square root of 12. Say for problem B, we have the square root of 98. And let's say for problem C, we want to simplify 5 times the cube root of negative 64. All right, so for problem A, okay, so we have square root of 12. Okay, so you want to factor 12 out to where you get a perfect square. Okay, so if you remember, 12, you could make it 6 times 2, but 6 isn't a perfect square and 2 isn't a perfect square. So we're going to pick 4 times 3. Because remember, 4 is a perfect square. Okay, so if we go ahead and break this down, our square root of 12, we can just make that square root of 4 times 3. Okay, so remember, we can separate it as soon as we multiply. So we have square root of 4 times square root of 3. Okay, so square root of 4 is 2. So we have 2, and that square root of 3 is not a perfect square, so we just leave it like that. Alright, so let's say for problem B, we have square root of 98. And remember, we have a lot of values we can choose from to factor into 98, but we want a perfect square. Okay, so if you think about it, 98, that's just equal to 49 times 2, where that 49 gives us a perfect square. Okay, so now we're going to go ahead and go through the steps. So if we started off with our square root of 98, we're just going to make that square root of 49 times 2. And remember, when we're multiplying, we can just go ahead and separate it. Okay, so that's square root of 49 times square root of 2. Okay, square root of 49 is positive or negative 7, but we're just going to use the positive. So that's 7 square root of 2. Or 7 times square root of 2, which is just 7 square root of 2. Okay, so let's go ahead to problem C. Okay, so every once in a while, they will throw a coefficient up in there. Okay, so a value right in the front, just another factor. Okay, so if we have 5 times the cube root of negative 64. Remember, as long as your index is odd, that value can be positive or negative. Okay, so we want 64, we want a perfect cube of negative 64. So if you remember, negative 64 is just negative 4 times negative 4 times negative 4. That means the cube root of 64 is equal to negative 4. Cube root of negative 64 equals negative 4. Okay, so if we go through each step, so if we have 5 times the cube root of negative 64, that's going to equal 5, because the cube root of negative 64 is negative 4. That's just 5 times negative 4, which is equal to negative 20. Okay, so it's the same process over and over and over. We're just keeping an eye on the fact that we can separate those two. Okay, now the one thing you want to remember is that you can separate. This is kind of an important note because it's very easy to make this mistake. You can separate multiplication of radicands. But not addition and subtraction. Okay, I'll give you an example of what I mean by that. So let's say, for example, if you have square root of x plus 4, that is not the same as square root of x plus square root of 4. You can't separate addition or subtraction. Okay, so to kind of give you a numerical proof as to why you can't do it, let's say you have square root of 9 plus 4. Okay, so we have 9 plus 4, we know that's 13, so that would be square root of 13. Okay, that's true. But let's say if you try to separate them. If you have square root of 9 plus 4, if you try to separate them, which we know you can't do, let's say square root of 9 plus square root of 4. Square root of 9 is 3. Square root of 4 is 2, which would be 5. So we already know that the square root of 9 plus 4 does not equal 5. Okay, so we know that's why we can't separate adding and subtracting, but we can do it for multiplication and division. All right, so now I'm going to provide you with some good to know values. Okay. So these are your perfect squares. Let me straighten that out a little bit. You don't have to memorize them, but they're good to know at least the first 4 or 5. Oh, move that up a bit. There we go. Okay, so you have your perfect square. So you have 1, which is 1 times 1, 2 times 2, 9 is 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, all the way down to 11 times 11. 144 is 12 times 12. So it's good to know them, at least be able to look at them and recognize them. Okay, you have your perfect cubes. Okay, you have 1 times 1 times 1 is equal to 1. 2 times 2 times 2 is equal to 8. 3 times 3 times 3 is equal to 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343, etc. And it keeps on going. Okay, so you have your perfect fourth powers, which is 1 to the fourth power. 1 to any power is just going to be 1. So you're always going to have that. Okay, you have 2 to the fourth power. 2 times 2 times 2 times 2. You have 3 to the fourth power is 81. Or 3 times 3 times 3 times 3. You have 4 to the fourth power, 5 to the fourth power, and it keeps on going. Then you have your perfect fifth powers. Again, 1 to the fifth power is just 1. 1 to any power is going to be 1. 2 to the fifth power is 32. 3 to the fifth power is 343. 4 to the fifth power is 1024, and it keeps on going and going and going. Okay, so again, you don't have to memorize them. It's just you want to recognize them in case they pop up, because they're more than likely going to pop up numerous times. Okay, so hopefully this made sense, and I will see you on the next video.